Hi, Nick.
Come on.
Wow.
You did that on purpose.
What? Me? Never. Why would I ever do anything like that?
Okay.
Well, that's true. You're never sarcastic.
Good luck
so it must not
today.
be false.
Probably going to be an afterthought.
But I'm saying-
All right, so arc length. I want to know the distance along a curve. Now, if this were string, we could pull it taut and measure it on a ruler. But we need to actually know how to do that. Okay? So we are going to derive a formula, pun intended, but it's really anti-derive a formula for us in order to be able to find the length of a curve exactly without having to approximate it. Okay, so let's just talk about, and you don't have to write this down. I'm just coming up with, I'm just kind of showing you where this formula comes from. Okay. Let's say I pick any random point on that curve, okay? And I want to know the distance from point I sub point P sub I minus 1 and point P sub I. Okay? There's 2 points. Really, I could use any notation I want. How do we find the distance between 2 points? Okay. Yep. We take the difference in our x's squared plus the distance in the difference, in our y's squared. Okay. What? Huh? Yeah, I'll enter square root. Okay. Now, could I describe this as a change in x? So basically we have change in x squared plus, I'm going to call it change in y squared. I'm going to do something crazy. I'm going to multiply by change in x squared over change in x squared. Am I changing the value? No. However, what happens? What does happen?
Like, are you multiplying the whole thing by it, or just the change of y squared?
All of it. Otherwise, well, what am I doing? Yeah, all of it.
This makes me feel confident. What? I lost. So lost. What?
So I'm going to distribute the denominator. Delta x squared over delta x squared is 1. Delta y squared over delta x squared is delta y over delta x, the quantity squared. And then I just kept the numerator delta x squared outside. Well, what's the square root of delta x squared? Okay. So now I want to take 2 arbitrary points and add up all of those teeny tiny distances, which means we're going to throw this into an integral. Okay? So we add up all of those teeny tiny distances, which means we're taking an integral. Boom, that's where the formula comes from. You don't have to understand where it comes from if you don't want to, but you need to know what is boxed right there. Richard, did you have a question? Okay. This is finding the distance along the curve, aka arc length. Now we have some formulas for arc length, right? A semicircle we could do without calculus. A line we could do without calculus. Anything else?
Triangle.
Linear. Okay.
Circle.
Said it
Really
already.
did?
I did. Yeah.
Why am I struggling today?
I don't know. By the way, I have your pictures and there's some
Ew, I hate seeing my
I have your
face.
pictures. Ew.
Whatever.
It's never gonna get let go, is it?
What is it? I feel like I missed something.
Yeah, you did.
It's okay.
Okay, so let's talk about what we need. You need the derivative. In an AP problem, they want to see that you thought about the derivative before you plug it in. Okay? And then you set up your integral. It's really as simple as that. Okay? Basically, where the trickery comes is if we are integrating by hand or not. If we're integrating by hand, we might need some tricks to help us get through our integrals. If we're integrating with a calculator, then it's not a problem. Okay? So let's do some examples where we integrate by hand. Oops. Algebra.
Yeah.
Algebra is the hardest part of calculus.
I think you yell in algebra.
Actually, yeah, algebra 1 was the only math class I've ever done like bad in.
I got a B plus.
In algebra
Wow.
1?
Yeah.
Yeah.
Miss Huggins
So
told me
Huggins
to
is
quit.
scary.
I didn't.
Yeah,
I
she-
honestly didn't like Miss Huggins.
Stop. Teachers are great.
She
All
Yeah.
teachers are great.
Yeah, I'm
that is
sure.
Not scary.
That's
loves her.
Mr. Castle.
What do you see,
Hey,
Mr. Castle?
we're done. We're done.
Mr. Castle is a legend. Do not disrespect.
I
that
saw him
man.
at school.
Yeah.
Yeah.
He's outside our time the other day.
Okay, we're basically finding that little chunk right there. What's the arc length of it? Okay? What did I tell you the first thing you needed to find would be? Your derivative. So our derivative. Caleb, what is it?
Me?
Yeah.
Oh. Well, it's an x squared and then over 2 plus negative 2 over x squared. Right? Now. Negative 2x to the negative 2.
So that 2 is going to stay in the denominator because it's already in the denominator.
Oh, I moved it to like that.
And easy mistake to do because you think, oh, it's attached to
I
x,
moved
it gets to
2,
move up.
yeah.
But no, that 2 stays in the denominator no matter what. It's a constant. Okay, so there's our derivative. I am writing it like that for a reason. Okay, so arc length is the integral from a to b, so they told us 1/2 to 2, of the integral 1 plus dy dx squared. And we're integrating this by hand.
BTW.
What?
I said it should and be too terrible.
It's not terrible.
That's some wishful thinking.
Okay, we are all masters of the algebra.
Well.
When we FOIL this out, we know we are going to get a squared minus 2ab plus b squared. We know that. So what do we get for a squared?
Couldn't we just like make common denominator and then like subtract them and then do it? And then just square both the top and the bottom.
Can you
No,
trust me on
do
this? Can you just trust me?
Follow her blindly.
You are not wrong, Caleb.
Let's just make it harder.
However, it's going to create more work at the front and at the back. And I'll tell you why here in a moment. Okay? 2ab.
-1/2.
Because the x squareds cancel and it would be -1/4, -1/4. And then b squared. Okay. Now, we can combine like terms because we have a 1 and a -1/2. Now, I'm going to do this strategically. X to the 4th over 4. 1 minus a half would be plus 1/2 plus 1 over 4x to the 4th. Why did I do that? Why did I do that? Why did I write it like that?
So you could put it into squares,
Well, you know how to factor this.
and then it's a double chain.
Do you believe me?
It's a double chain.
Look at this right here. And look at this right here. The only difference is this subtraction sign, right? So we know without having to think too hard that this is going to factor to x squared over 2 plus 1 over 2x squared, the quantity squared.
Could be a double chain rule.
We don't need a double chain rule, and there's no such thing as a chain rule in integration.
But you could.
No.
I feel like it'd be more fun.
No,
Wait.
it would not work at all.
I'm a little lost.
It would not work at all.
How did we get
Yeah,
from
how
the
did we
step
get there?
there to there?
It's the same
Okay.
as the top one.
So do you notice how this trinomial is the same as this trinomial except the addition subtraction sign right there?
Yes.
So if this trinomial factored to this,
Uh-huh.
then this trinomial would factor to the same thing but with addition.
Okay.
There's a lot of work here.
How would
This
you
is a lot of
recognize this normally, though? Like, if you were just doing this, so you have to kind of, like, be able to recognize that, like, something like that would happen. ahead of
Which is
time.
why we're doing this problem together. So when you get to a problem like this, you'll think, oh, we did one like this. I know what's going to happen here. I've seen this before.
I don't know what to look for.
A pattern.
Hmm.
Okay? A pattern that repeats. So this trinomial was almost the same as this trinomial.
Okay.
Okay?
I get it.
That's what you would look for. Okay? And then this was beneficial for us because now the square root and square can cancel. And we have the integral from 1/2 to 2 of x squared over 2 plus 1 over 2x squared. Richard, what's the antiderivative of x squared over 2?
I put the 1/2 up front.
Oh, Richard did this.
Very nice.
Is that allowable?
Of course.
Okay. I like it. He's thinking ahead. Now what's our antiderivatives?
1/3.
Evaluated from 1/2 to 2. I'll save you the trouble.
I appreciate that.
2 and 1/16. Miss Holman, how do you feel about mixed numbers? You know, like 2 and 1/16.
I dislike them. How did you know that?
How did I know that?
Yes.
I don't know.
Like literally this morning, I asked my first hour, or I told my first hour, you know how I feel about mixed numbers. I dislike them strongly. However, I will allow you to use them in today's graphic.
Well, he just
you,
said
like-
to himself
Why
that
do
it
you
was
just
2
like
and
that?
1/16.
Yeah.
So that he was like,
They're
It's annoying.
inefficient.
why is it inefficient?
But they're
Because
if
if
it's
you
like
Did
2
you
and
know that?
1/16,
they're nice
You
ones.
have to understand that I am a psychic. I just know these things.
Who are you friends with?
I don't have any friends.
My second hour.
I don't have any friends in your second hour either, as far as I know. I know nobody in those
I know.
first two.
That's just strange that you asked me that because I literally today said I dislike them strongly.
I just thought 33/16 saw it was easy to turn into a mixed number, and then decided, you know what? Math teachers hate mixed numbers. I'm
Well,
gonna bring
it's
that
true.
up.
I do not like them.
Like if you're trying to make it easier for someone to know what that means quickly. 2 and 1/16.
Well, at that point, just decimals.
But you all know that.
2 and
Yeah, I know, but,
1/16
like,
is
it'll-
easier when
like,
you're
if I look at
cooking.
this, it'll take me a second.
Yeah, I did not know it was.
Like,
Does it take up less space? Yes.
yeah.
That's
Yeah.
2.0.
Okay.
Oh.
All right, now,
That's 1/2.
do you believe that this gave us the right answer?
Sure.
Get out your calculators.
Oh,
that's
impossible.
It is the right answer.
What I want is for you to find the straight distance.
Dude, one of these days we're
The
gonna go through
displacement.
all of this, and it's gonna be
What we're
wrong.
doing?
Like,
Like the displacement of the.
What am I putting?
what over here? Oh, way up top. What's the y coordinate if x is 1/2? Find it for me. Find it for me.
Ah. Oh no.
49/48. And 2
You have a calculator in your hand right now.
Hey, you're not doing it either.
8 6
I did what you.
plus 1/4.
8, 6 plus 1/4. Those are both fractions. I don't know what to do.
Thank you, Ben.
38.
Okay, so 19/12. Okay, use the distance formula and find me the distance between these 2 points.
Just displacement.
My idea, 83 plus is
Is that like not the.
not okay with it.
Use the distance formula, please. We're not doing motion or anything like that. Just like we're literally talking about, Caleb. We're literally talking about me putting a ruler and measuring the distance between these 2 points.
Yeah, but that's not gonna get you the same thing as the arc.
No, it's not.
Okay, I thought you were trying to check our answer, and I'm
Nope,
like, this
find
is
it.
not the same thing.
We're thinking about if our answer is reasonable.
So it should be greater than this. Like,
Yes.
yeah,
You are right.
that's what we're testing for.
Why wouldn't we just plug in the
Just
actual like
find
integral?
the distance. We don't need to check our work. We were perfect.
It's true. We were perfect.
Yeah, I think I did it right.
I forgot the distance one.
Right.
We literally
We
went
just
over
did it.
Not even 10 minutes ago.
Yeah, do you?
Not even 10 minutes
Yeah.
ago.
You get 1.6.
That's what I got.
Hey, that's what I got.
Yeah,
Okay, which is less than 33/16,
but it's
Or
straight.
2.0625.
which it should be because it's a straight distance while we're curving.
Oh, now I remember.
We didn't really check
You
our
wrote
orders.
it out.
That's what I meant.
Oh.
Would you like to put the integral in to verify that it's 33/16? Would that make you feel
12?
better?
I did.
Yeah.
You did?
Yeah.
And Zane, what
12.
happened?
Why you? 33 actually.
It is plus.
Look at that, we were right. Thank you, Zane, for
I-
helping us out.
Just saying
Check.
blindly.
So I guess
I swear it was minus
Whatever.
0.
I just wanted us to think about the difference between arc length and distance formula, right? Our arc length should be greater because we're curving around wherever function we're on. Where the straight distance is going to be smaller because it's a straight shot, right? If you could go from Nick's house to Richard's house, if there weren't any houses in the way, it would be a lot faster than having to go on the grid.
Only two turns.
I always say,
But like if there weren't any houses,
I always say like the bird's path.
the bird's eye view.
Bird's path, yeah.
Yep.
Personally, I like to pretend that houses are there when I go into a place.
The monster truck path.
I really want to put a zip line, like we have neighbors behind us, a couple houses down, that we often get our families together. We've talked about just like doing a zip line instead of having to go like all the way around the block. Just
Alright, we'll make it happen.
But-
thank you.
But zip lines
My
only
future-
go one way. You don't get to like.
Or
and then
think
we
of-
would have to make two of them.
Yeah.
Or you could
Or you
use
put on a crane.
what if you
Okay,
use
this is our
technology?
next one.
Motor powered.
Motor powered.
I have a graph for you. This is the natural log of cosine of x. Cool. I want the arc length from 0 to pi over 4. Just write down what you need to. We'll work through it together.
Your friends also do math.
So you basically have to design it when.
But that's okay. My husband also does math.
So you'll just make him do it.
No, one teaches Education Academy and what's that class? Like medical terminology or whatever. And the other one's a nurse.
No.
Okay, when we find arc length, the first thing we need to calculate is the. Find it for me.
I write.
Oh, I have to remember how to do this now.
Negative tangent, right?
Oh, that's one way. Look, I did cosine.
Okay, the derivative of chain rule. This is a chain rule, right? This is what I taught last hour. Okay, the derivative of the natural log is 1 over what's inside times the derivative of the inside. Well, what's negative sine of x over cosine of x?
Negative sine over cosine. Or that.
Okay, now, why am I so excited about this? Our arc length from 0 to pi over 4 of the square root of 1 plus tangent squared x. Isn't that convenient?
Super convenient.
Isn't that like a thing?
What is 1 plus tangent squared the same as?
Cosine, no.
Nope.
That's not it.
Cotangent.
Nope.
Tangent.
Nope.
Let's just throw out these until we find one.
Wow, you actually almost said it.
Nice.
So close.
I believe
Like
he
this is a
actually-
Pythagorean identity that
Oh.
you knew from 2 years ago.
Yeah.
Just throwing that out.
That was
Yeah.
2 years
I
ago.
can't remember
If
that.
it's from 2 years ago. Yeah.
Please remember that sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared.
That's not really good, but it's not good. Yeah.
Well, you need to be able to recognize it, yes. For what we do this chapter and the next chapter. You'll remember. Alright, so what we have is 0 to pi over 4 of secant of x dx. Cool, what's the antiderivative of secant?
Negative sign
Well,
Ugh.
is this one of those ones we were supposed to memorize?
Nope.
It's literally 1 over tau times derivative.
So it is.
Yeah. So,
1/2 secant squared. No, 1/2 something.
If secant is 1 over cosine, it's natural. What's going on right now? This was one of the ones we had to memorize.
No, it's not.
How was I
It's not.
supposed to?
Because it's
So this is one you would have to
1
look up in
over
your book.
Cosine.
This is one you would have to look up in your book.
That's
In the back of your book. So the
Right.
antiderivative for secant and cosecant are not ones that we have something for. You would have to look them up in the back of your book.
okay.
Do you have a book?
Yeah, but
Then no.
What about on a test though?
Well, then I would need to provide it.
I guess.
Okay.
you really just set us up to fail right there. Asking us what that was.
She was just looking for that one kid who's got the entire back of the book memorized.
No, I was just seeing if you could think through whether we knew it or not.
We did.
I mean, technically.
But I think if it was cosine, some of you might have been confused too.
I mean, technically.
Just kidding. I have faith that you know the antiderivative of cosine. Okay.
Yeah, it's
So we have the natural laws of what's the secant at pi over 4? What's the tangent at 1? Minus the natural log. What's the secant at 0?
One.
Plus the tangent at 0.
0.
Lost in my-
Yeah, my brain,
We should just get rid of the natural log of 1 because it's just 0.
Can we? Is the natural log of 1 0?
I have to concur.
good catch.
Nice way to use that fancy word.
There you go.
See, with my handwriting, the answer is such a natural log of the absolute value squared 2 plus a.
If we like left the absolute value sign in our answer,
I'm
even though
never going to be upset about that.
okay, even though like you can't get negative numbers anyways.
I know.
Right, and that's why I left it off.
Yeah.
Okay, but if you have the absolute value sign, that's never going to upset me.
Okay.
All right, that is a very important BC topic. That's going to pop up in almost every chapter we have. When we talk about polar, when we talk about parametric, we're going to talk about how to do the arc length and those sorts of equations. Okay? Now, we are also going to talk about surface area, at least just for Cartesian coordinates. Okay? We have 7 minutes. Are you worried? What? That's fine.
Fine.
Don't write this down. But consider a curve and we rotate it about the x-axis. We can take a little piece of that. How would we find the surface area? Okay. Well, 2 pi r would be the circumference, right? Times however wide it was, right? Kind of like a rectangle we would like cut and lay out. Okay. So I have, and then we have to like add all of those up.
It's like a belt.
Yes. 2 pi r, and then we add them all together. Well, the radius is just going to be our arc length. Well, not the radius. Excuse me. Let me. dx. Sorry. This dx is our arc length. I'm sorry. I misspoke. Y is still going to be there.
Now that's
Okay, so we have to
It's
write that down.
just this.
So what is it? It's 2 pi y times arc length. That's it. 2 pi y arc length. Do you see it?
I just said Cartesian.
Because
What else would it be?
polar.
Because this would not be the same for polar or parametric.
What's parametric?
You know when you like throw a ball?
Y equals and x equals a function in terms of a third variable, typically t.
I don't know what that is.
What?
In which case do you just
Just a little example here, like a point.
Are you kidding me? You're not recognizing it?
No.
It's literally from physics. We've done this.
Isn't it just like x
We
squared?
can do this.
There are arrows.
Isn't that just like a function x
What are
squared?
the arrows for?
You know how you
Because
do
it
the
has
two-way-
direction.
Oh, it's
As I
it's like
plug
an
t
vector.
values in, we follow the curve.
Parametric.
So it's never
I
like.
do that on like a Cartesian.
I guess, yeah,
as well.
I guess that makes sense.
Can you not have like
But-
one point? Just like a.
So
point
like
on
when
there?
we apply it to like physics, t typically represents time.
Yeah.
So if we have some sort of like projectile motion problem, we can talk about the horizontal distance separately from the vertical distance, but still all in one equation.
Oh, I remember that. Projectile motion.
We'll get there at the end of the semester. Okay, yes,
Can you change that to f of x and f prime of x?
if you want to.
Okay, it's just kind of messing me up that there's a y and then it's in relation, then you do need dx.
Okay, so can we go to our example? Y equals radical x. That looks like from 0 to 9. Okay. Well, what's y prime? One half x to the negative 1/2, right?
Yep.
Cool. So surface area is the integral from 0 to 9 of 2 pi y arc length. That's wrong as a bet. Because guess what?
Chicken butt.
We were so close to making it to the
Very classy, Richard.
We can-
We're all proud.
It's true. We can throw the 2 pi on the outside, and then we can actually multiply these radicals together. So this becomes x plus 1/4 under the radical. And that becomes a pretty simple antiderivative.
0 to 9 because it's the graph.
Yeah, I gave you the graph from 0 to 9.
Okay.
So a minute.
I think it's like 5 seconds.
It's not.
Okay.
So this is x plus 1/4 to the 3/2 times 2/3 evaluated from 0 to 9. And then you can work your magic there. Wow, those 5 seconds are really dragging.
This clock is very wrong.
Like we still have another like 40 seconds until it will ring. Okay. I am most concerned about arc length, yes. However, arc length and surface area will both appear on your quiz Thursday, not Monday. Thursday.
Well, it's Monday for me.
Looks like you're muted.
No, I promise.
It was Caleb.
The following students have not had their pictures taken and need to report to the site arena. Michael Bonke, Miranda